Welcome to RLD Academy. In this video, we are going to discuss few problems on the following topics: the one-to-one function and on-to functions. In particular, these three functions or three problems will be discussed in detail. So these three functions, one is f of x equals to x upon 1 plus x. Second function is 2x plus sine of x. And third one is absolute of x times x minus sine of x. And for these three functions, we need to find out whether function is one-to-one function or not. And again, the function is on-to function or not. So this kind of choice could be given in the problems. Actually, these three problems appeared in JEE papers. First problem appeared in JEE 2003, second one JEE 2002, and the final one is the advanced problem. It appeared in 2020. So I am discussing this kind of problems in my channel for last few videos, and I am saying that these kind of problems are coming regularly in JEE papers, either in main or advanced. So don't skip this part. Try to understand this part well so that you can solve this kind of problems easily. Okay. So we'll be discussing these three problems. Okay. And in my previous video, you can see that I have discussed this concept one-one and on-to function. Okay, this is the video, and the link is given in description as well as at the end of the video. So if you want, you can go through this video after this, going through this video, current video, right? So, but this is an interesting video one. There I have discussed in detail what is the meaning of one function and on-to function. But in this video, we'll briefly discuss again the concept of one-one and on-to. Then we'll solve this another three problems. Okay. So we'll solve the first problem, and before solving this one, what I will do, I will try to find out or try to discuss this concept that what is one-one and what is on-to function. So if I consider x is one independent variable, then the function f, I will get the function value f of x. Okay. This is, I have said that this is called input function or input domain. This is your input, and this one is called output or image, right? So we need to choose certain inputs, and for those values of input, we need to find out the function value, and that can have certain values. So this range or interval of the input is called that. This is, I write in different color. This is called domain, and this will be called as codomain. Okay. So these are the two important concepts, that what is the domain and codomain. In this case, this range is specified. This is the domain defined for the function, and this is this one interval 0 to infinity, all real numbers, positive real numbers. This is the codomain. Okay. Now, so what I am saying that if I have one input space, suppose if I consider this is one input space, and this is the corresponding output space. So I can have some input point. So these are the few points on input space, and these are few points on this output space. Then if I choose one point of an input, then I can use this function. I'll get one mapping f. Then I'll get corresponding point on the output space, that is called image. Okay. So this is the corresponding image of this input, right? So this is x, and this one is f of x. Now here we need to understand that how function f of x will vary for those inputs. And if function f of x is limited, so this f of x is bounded within certain minimum value and its maximum value, okay, I'll put equal sign, then we can say that the image points are bounded within this interval, this f max or f past mean and to f max. This interval will call it range. Okay, so if the range covers entire codomain, then it is called onto. For onto, what is the requirement? So for onto, the requirement is that this range should be same as this codomain. Sometimes we will find that range is a subset of codomain. If range is subset of codomain, then it is not a onto function. So this is very simple. So what we will do, we will consider codomain, domain and range. We will find the range. If range is same as codomain, it is a onto function, right? And what about then one-to-one function? For a one-to-one function, what we will choose? We will choose one image, and image is coming, if the image is coming from only one input, so one image we will get from one input, then that kind of mapping is called one-to-one mapping. Okay, but sometimes we can find that this kind of things. So this is your input and this is your output. Now this point we are getting from this input as well as this input. The same image we will get for two inputs. Then it will be called many to one. This is many to one function. But if this is not the case, if all time you will get this kind of connections that every image is coming from only one input, okay, then it is called one-to-one function, right? So how to conclude these things? So easy way is that for continuous function, okay, so I am considering only for continuous function, and discrete functions will be discussed later in some video. Okay, for continuous function f of x, so f of x, if it is increasing function, monotonically increasing or monotonically decreasing function, then that time we will get one-one connection. Okay, if function is either increasing monotonically or function is decreasing monotonically, then every time the image will be coming from only one input, not more than one input. You will get this because monotonically it is increasing or decreasing, thus it is one-one connection, okay, one-one mapping. But if it is not so, within this domain, what is happening, sometimes it is increasing, sometimes it is decreasing, then you can find more than one input which will produce same image. In that case, it will be many to one function. So this is very useful concept. You should remember this thing. If function is monotonically increasing or monotonically decreasing, not simultaneously, then it is one-one function. Okay, and for onto function, what is the requirement? The range should be same as codomain. It should not be a subset of codomain. If range is a subset of codomain, then it is not a onto function. Okay, this is very simple. These two things. Now we'll try to solve these three problems to identify whether function is one-one or onto function or not. Okay, so let us consider. So this is a function. So the function f of x is x upon 1 plus x. And you know that, as I said, this is your domain and this is your codomain. Okay, so first we'll try to understand whether function is increasing within the domain or not, or function is decreasing. Okay, what is this? To check whether function is increasing or decreasing, what you will do, the first step is that you find the derivative of this function f of x. So f prime x means derivative of f with respect to x. This you will find out. Okay, and for this one, so whatever you will get, so if this value is positive, that imply it is increasing function, and if it is negative, that implies it's a decreasing function, and if it is 0, that time the function is having maxima or minima. Okay, so we are interested for these two, whether function is increasing monotonically for entire range of this domain, entire interval, or it is decreasing or not, right? So this is a function, and this function we can rewrite as, so this x plus 1 minus 1, I can put it here because 1 will cancel out, then it is x plus 1, so that one it is 1, so this by this will become 1 minus 1 upon x plus 1. It will simplify a little bit. You can go through, you can use the same function as well to take derivative, but if I consider this one, then from this we can easily find out its derivative. So first term 1, its derivative is 0, it's minus sign. Second term, its derivative is minus, so this is 1 upon x, its derivative is 1 upon x square, 1 upon x plus 1, that square, right? So this minus and minus, it will become plus 1 upon x plus 1, that square. And as it is a squared form, so this is always positive, is more than 0, right? So never it could be negative. It is, and it's 0, you will become at infinity only. At infinity it will become 0. That's fine. So for 0 to infinity, this value is always positive. That implies that f of x is a increasing function. So it is a 1-1 function. It's solved. First part is solved. That function is 1-1 because it is strictly increasing function. Okay, for entire 0 to infinity. Always it is positive. This derivative is positive. Okay. Now what is the range? Okay. So as it is increasing function, so it will start from f of 0 is the minimum, and f at infinity it will have maximum 1. So what is f of 0? That 0 upon 1 plus 0 is 0. And what is the infinity? F at infinity, it will become infinity upon 1 plus infinity, and that will be your, that will cancel, so it will become 1. So 1 is very small, x and x will cancel, it is approaching to 1. Okay, so what is the range then? So range is simply, this is 0 up to 1, right? So you can see that this range is up to 0 to 1 only, but the domain is, codomain is given 0 to, it is subset of codomain, because it is subset. Why? Because codomain is mentioned as 0 to infinity. Okay, but it is only 0 to 1. Thus it is subset of this codomain. It does not span entire codomain. So it is not onto function. Okay, so it is clearly, it is on function but not onto function. So our choice, if it is given that it is a 1-1 and onto, no, it is a onto but not 1-1, it is not correct. It is a 1-1 but not onto. So this is the correct answer for this one. Right? So I hope you have understood this point. Right? Now we'll move to next problem. So this is the second problem, f of x. Now quickly we'll solve these things. So f of x is given by 2x plus sine x. So what is the derivative? So first 2x derivative is 2 and sine x derivative is cos x. And you can understand that the cos x is bounded within plus 1 and minus 1. This is the range for cos x for any value of x. So cos is a periodic function. Its maximum will be 1, minimum will be minus 1. Thus, if I add 2 on both sides, it is 2 minus 1. This is your 2 plus cos x. That should be 2 plus 1. Okay. So this side is 1. It is 2 plus cos x. That is your 3. So it's other words, this is more than equals to always 1. So if it is more than 0, it is sufficient for us because it is positive. As it is positive, this implies that this f of x is an increasing function. Is always more than 0. The derivative is more than 0. Okay, so it's an increasing function, thus it is 1 function. Correct? Now what is the range for this one? Okay, so you can find out. So this is given, this 0 to, this is R only. Okay, so this is its domain, this is your domain, this is your codomain. So codomain is given all real numbers, minus infinity to plus infinity. Now we need to understand this one, this function. What is, so you can see that this is an odd function, f of x. So 2x plus sine x. This is odd function. This is sine x is again odd function. Combination of these two odd function is again an odd function. So fx, odd function means what? F of x equals to minus of f of minus x. Okay, that is your odd function. So right side, whatever value we will get, left side will get just negative. That's all. Now as x is approaching to infinity, you can notice that this first term, this term will become infinite, and this term is bounded within 1. Okay, 1 minus 1. So its value is approaching to infinity. So obviously f of minus infinity, it will approach to minus infinity. So you can see that, so this f of x will span from minus infinity to plus infinity. So this f of x within this entire range, minus infinity to plus infinity, thus the range is simply minus infinity to plus infinity, and that is your R. Okay, it's same as codomain. So range and codomain is same, thus it is onto function. Okay, this is correct. So it is both 1 and onto. Okay, so if these choices are given, so I can say that it is both 1 and onto function. It is solved. Now we'll move to the next problem. This one, it is an advanced problem, but very similar to the last one. So only the change is these things. It's a mod function given. What is f of x? It's the mod of x times x minus sine x. So what is the mod x? It's the even function. And this is odd function because the combination of two odd is odd. So why? Because mod x is like this. For positive, this is x, this is mod x. So mod x equals to x for x more than 0, and this is equals to minus x for x less than 0. I can put equal sign anywhere. Okay, so left side also it is positive. So this is your mod x. It's an even function, right? So even function or odd function, if I multiply, this total function will become odd function. So need to understand what is even function, what is odd function, and it will play a big role to understand the range, everything. Okay, so now what I can say that f of x for positive x, so mod x is replaced by x only, and it is x minus sin x. This is for x more than 0, and this for negative x, this mod x is replaced by minus x. It will remain same, sin x for x less than 0. So I can put equal sign anywhere, that is not a problem at all, right? Now, what is the derivative of this one? Now, before that, I will consider only one side. Only I will consider x more than 0. So for that, the f of x is x into x minus sin x. So what is your derivative of this function? I can keep this part constant, x minus sin x. Derivative of x is 1 plus x will keep constant, and derivative of this one will be x derivative is 1 and sin derivative is cos. Okay, is it okay? Now what you will get, so this way if I multiply these two, so this is x, here also x, I will get 2x minus x cos x, and this is your minus sin x. Now you need to understand this function, whether it is positive or not. So x I can take common from these two, it is 2 minus cos x, okay, minus sin x. Now as I discussed earlier that this part 2 minus cos x is limited within plus 1 and minus 1. So obviously this 2 minus cos x is more than 1 always, okay. So this is more than equals to x into 1, that I can put minus sin x, right? So because 2 minus cos x is more than 1, that we understand, more than equal to 1. And again this x minus sin x, x is always more than sin x, because if I plot this one, this is your x and sin x will be like this. Okay, this is x, this is your sin x. So x is always more than sin x, that we understand. So this is again more than, so this difference will be more than equal to 0. And equal sign will be there, it will be at x equals to this equal sign. I will have only some points only, not the range, okay. When, so x could be 0, or when this will become 0, means x equals to 2 pi. So x equals to 2 pi n, that kind of things, and those values, this equal sign will be there, okay, it will be 0. But those are the points only. So it is not an interval. So this is increasing. So this is more than 0, means monotonically increasing function. Okay, so right side, when x is more than 0, the function is increasing. As it is an odd function, right side if it is increasing, left side also it will be increasing. So there is no need to compute again for x less than 0, because it is an odd function. If right side, so what we can do, if I show these things, this plot, suppose this function, this is the x, and we have seen that it is, I said it is increasing, suppose it is increasing like this. If it is odd function, it will look like this. Okay, so if it is increasing, this will be also increasing. Okay, so entire function is an increasing function, is an increasing function. Okay, so f of x is increasing function always, and if it is an increasing function, right, so what do we consider? So this one I can consider that f of x is one increasing function, thus it is 1 1, right? Now we need to understand, so again, so you can see the graph for that. So from 0, at 0 it is 0. What is the value at 0? F of 0, obviously it is 0. And what is the value at f of infinity? You can notice that this part is infinity, this part is limited to +1 and -1 only, so it is going towards infinity. Similarly, f of minus infinity is also going towards minus infinity, because if we right side this shape, left side will be this shape. Okay, that's minus infinity, this side is minus infinity, plus infinity, this side it will go to plus infinity. Okay, so this range is again this plus infinity, minus infinity to plus infinity, means entire real axis, and that is your codomain given. So in this problem again we have found that it is 1 1 as well as it is a onto function, because range is same as the codomain, it is again onto function. Okay, so the 1 1 as well as onto function. So we'll be discussing several problems like that, right? And we'll discuss some integer type functions, not only continuous functions, discrete functions, in the next videos. So keep watching, I'll be discussing more problems. So thanks for watching.